Hey everyone and welcome. Today, we're tackling a really interesting design problem from Leetcode called Design a Food Rating System. It's a great exercise in choosing the right data structures to make our operations fast and efficient. Let's dive in and break it down. So here's the core task. We need to build a system that can handle a list of foods, their cuisines, and their ratings. It needs to do three main things. Initialize the system with some starting data. Let us change the rating of any food, and, this is the important part, quickly tell us the highest rated food for any given cuisine. Let's look at the three functions we need to implement. First, we have the initializer or constructor, which takes in three lists: the food names, their corresponding cuisines, and their ratings. Then, we have change rating, which is pretty straightforward. You give it a food name and a new rating, and it updates it. Finally, highest rated is our query function. You give it a cuisine, and it needs to return the name of the food with the highest score in that category. Now there's a crucial detail we can't miss: the tiebreaker rule. What if two foods, say sushi and ramen, both have a top rating of 16? The rule says the food with the lexicographically smaller name wins. In simple terms, that means the one that comes first in the dictionary. Since ramen comes before sushi alphabetically, ramen would be our answer. This is a key requirement for our design. Let's walk through the example to see this in action. We start with some initial ratings. If we ask for the highest rated Japanese food, it's ramen with a score of 14. Now let's say we change sushi's rating to 16. The next time we ask, sushi is the winner, but then, we also change ramen's rating to 16. Now we have a tie. Both are at 16. So we apply the tiebreaker rule. Ramen comes before sushi alphabetically, so ramen is the correct answer. So what's the real challenge here? The highest rated function. If we have thousands of foods in a cuisine, we can't afford to scan through all of them every time we get a query. That would be too slow. We need a way to look up a food's info instantly, and more importantly, a way to find the top-rated food for a cuisine very quickly. This tells us we need some smart data structures. Our first approach uses a classic combination: hash maps and priority queues. The idea is to maintain a separate priority queue, or a max heap, for every single cuisine. A max heap is perfect because it always keeps the largest element at the very top. This way, finding the highest rated food becomes an O of 1 operation. Just peek at the top. We'll also need a separate hash map to quickly look up any food's current rating and cuisine. But there's a catch. Heaps are not designed for easily finding and updating an item that's buried somewhere in the middle. So what do we do when a food's rating changes? The answer is a clever trick often called a lazy update or lazy deletion. Here's how it works. When a rating changes, we don't even try to find and remove the old entry from the heap. We just leave it there. Instead, we simply add the new, updated rating to the heap. This means our heap might contain some stale, incorrect data. But that's okay. When we need the highest rated food, we look at the top item. We then use our other map to ask, is this the real, current rating for this food? If it's not, we know it's a stale entry, so we just pop it off and look at the next one. We keep doing this until the item on top of the heap matches the real, up-to-date rating. Here is the full code for the priority queue approach. In the initializer, we populate our maps and push the initial ratings into the correct heaps. Notice we push the negative of the rating. That's because Python's heap queue is a min heap, so using negative numbers makes it behave like a max heap. The change rating function simply updates our info map and pushes the new rating onto the heap. And finally, highest rated contains that cleanup loop we just talked about. It keeps popping stale entries from the top until it finds a valid one. Now, that lazy update approach is clever, but it feels a little messy, right? Our heaps can get filled with old data. This leads us to approach 2. What if we used a data structure that's always sorted, but also lets us efficiently add and remove items? A balanced binary search tree, or a sorted set, is exactly what we need. While Python doesn't have one built in, the popular sorted containers library has a sorted list that does the job perfectly. With a sorted list, the logic becomes much more direct. When a rating changes, we first find the old rating. Then, we explicitly remove the old entry from our sorted list. After that, we add the new, updated entry. The sorted list automatically puts it in the correct place to maintain the sorted order. This means no more stale data. And finding the highest rated food is as simple as taking the very first item from the list. And here's the code for the sorted list approach. It looks quite similar, but notice the key differences. In change rating, we perform an explicit remove before we add the new value. This keeps our data structures clean, and look how simple highest rated becomes. It's just one line. We access the sorted list for the cuisine and take the first element, which is guaranteed to be our winner. So let's compare their performance. For the heap-based approach, initialization and changing a rating are both logarithmic time, which is very good. Finding the highest rating is also typically logarithmic, but in a worst-case scenario with many stale entries, it could be slower. For the sorted list approach, the performance is more consistent. Change rating is logarithmic because it has to find, remove, and add an element. But highest rated is a blazing fast constant time operation, just an array lookup. The sorted list approach is generally more reliable and performant. So to wrap up, this problem is a fantastic example of how picking the right data structures is crucial for performance. Hash maps gave us the fast lookups we needed. And for the core challenge of finding the highest rated item, we saw two great solutions. The priority queue with its clever lazy update trick, and the more direct and robust sorted list approach. Both are excellent patterns to have in your toolkit. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.